Да, они там южные до севера, по-моему, да, она была
Good evening. Thank you all for coming. This is actually exciting to have you guys all come in to this talk. Cassandra is really a hot topic, so I'm really glad to be able to organize it here at Walmart Labs. We have this tech talk in cooperation with CodeChicks. And it's a women developer group, and I'll introduce the group and she'll tell me more about it.
Cool, thanks, Salima. Hi, everyone. Need to fix this. Halfway through, that should be okay.
That should.
Okay. Yeah. All right, welcome to our CodeChicks technical talk on Cassandra. Today we have Patrick McFadden speaking to us about how to build an application using Cassandra. And I'd like to take this opportunity to thank our sponsors, Walmart Labs, for the food and drinks and the great venue. And thank you for supporting CodeChicks and our cause. And a special thanks to Salima Fasil, who's sitting right here. She's our CodeChicks organizer, and she organized this event. So please do give her a round of applause. I'm going to talk a little bit about CodeChicks and who we are. CodeChicks is an educational group for female developers and geeks, and we focus on face-to-face interaction and have monthly events, roughly monthly. Most of our events are open to men and families, so it's not just women only. We are completely volunteer run, and we run on your generous donations. We're currently in the process of filing for nonprofit status, and hopefully in the next few months we'll have it. Here are some of the events that we do on a monthly basis. Sometimes we do once a month, or sometimes we do more than one event a month. We have tech talks like this one today, which is usually on a weekday evening for a couple of hours. We also do workshops, which are on weekends for about 4 to 5 hours, and those tend to be instructor-led and hands-on training. We have hacking sessions, which are very open and free format. So you just bring your project and you work with other people, or just hang out. And we also do an annual speaker series, which is for principal engineers and executive speakers, CEOs, CTOs, and they come and talk to us about their projects and products. They have to show code, they have to demo it, and they have to answer Q&A. So that happens once a month. We've had about 19 events this year, which is quite a lot for any group. So hopefully next year is going to be equally successful. And most of our events are posted on codechicks.org, which is our site. So if you're curious about what's coming up, just go there and you'll see all our different chapters and what chapter is hosting what kind of event. Here are some of our goals. So what we're trying to do is have a continuing education forum for female developers and other developers also through our workshops and tech talks and hacking sessions. And we've just started a group series on the MIT Python course. We're also trying to promote female developers and engineers and create a community for mentorship and guidance. So please do check us out on codechicks.org/about-codechicks. And here are our chapters as of today. So we have the Bay Area Silicon Valley chapter, which is led by me. I'm Rupa Dasher. I started CodeChicks in 2009 in my living room in San Jose. And now we're up to about 200 female developers in the Bay Area. And we have chapters in Seattle and Redmond, led by Shaili Guru. And we have a chapter in Los Angeles, led by Laura Mann. And I'm in the process of onboarding Virginia and Washington, D.C. And next year, we're looking at Germany and India and China. And so we would love to have you spread the word about us and our chapters so we can help women developers all over the globe. These are some of the past events for this year. We've had graphic design for engineers workshop. We've had Wikipedia engineering come and talk to us about their backend infrastructure. And we've had Sarah Baker come and talk to us about toy robotics, specifically Pleo the dinosaur and how to program him. That was a big hit with the kids. We've had a couple of workshop series, one on Android installing and building Android apps, and another one on Red Hat's OpenShift PAS platform. And we are currently doing an MIT Python group study for certificates. So if you sign on and you take the class, which is online and it's free, and you do all the homework and the test, you get an MIT certificate. And so here are upcoming events for the rest of the year. Today we have the Cassandra Tech Talk here, and December we're kind of taking a holiday break and going to have a holiday potluck party. And next year we're booked up in January, we'll be at Google. February we are trying to get in Facebook to have them host us. And we're looking in March, we'll have a big presence in PyCon because we are very strong Python advocates. And in April, maybe we can pair up with DataStax and have a workshop on Cassandra. I got you. So we're growing, and so we have growing needs too. So here are the things that we need help with. We're looking for organizers in the San Francisco and Berkeley area to organize all our events. We're also trying to raise funds for our 2013 t-shirts. We were wildly successful with our 2012 t-shirts, so we're completely sold out, and people are asking about them. So we want to raise about $1,000. We're up to 200 right now, so we still have 800 more to go. Also, we're looking for chapter leads at other geographical areas, both domestic as well as international. And for our nonprofit side of things, we're currently looking for a CFO/treasurer. So if you're interested or you know someone who's interested in volunteering, please let us know. So the ways to let us know are through our website. You can email us at organizers@codechicks.org. Or you can just tweet, put our handle @CodeChicks, and we'll get it. So please come join us and improve your skill set. And just wanted to put all our social feeds on there. We are on Facebook, we're on Twitter, Google+, LinkedIn, and our hashtag is #CodeChicks. And our motto is "May the code be with you." And so feel free to check us out on codechicks.org. We work pretty hard to keep up that site. And that's it about CodeChicks. I'd like to introduce our speaker today. So Patrick is a Cassandra MVP and Principal Solutions Architect at DataStax, specializing in data modeling and operations topics. Prior to this position, he was Chief Architect at Hobsons, an education services company. His responsibilities included ensuring product availability and scaling for all higher education web products. He came to Hobsons after they acquired his company, Link 11 Systems, which was a software services company. So while at Link 11 Systems, he built the first widely popular CRM system for universities called Connect. He obtained a BS in computer engineering from Cal Poly in San Luis Obispo and holds the distinction of being the only recipient of a medal. I screen blanked. Of a medal for hacking while serving in the US Navy. I've got to ask him about that. So please welcome Patrick.
No, do I need that? Oh yeah, you do need that. Okay, let's switch computers. Yeah, one thing I should talk about in the Navy experience was I was in the Navy when. Well, I joined the Navy when Grace Hopper was starting up a lot of her stuff. Yeah, and I actually saw her at a conference in the 80s, and she's the neatest lady you've ever seen. She's really neat, though. She, started a lot of stuff in IT. The COBOL language, got a lot of things underway, especially in the Navy, like logistics and making sure that computers were at the forefront of a lot of that. And when everybody was saying, that's not a great idea, she was a tough one. I mean, she would smoke Lucky Strike cigarettes. She was that tough. And she just basically barreled this thing through. So, that's my coach's connection. She was the original coaching. Actually, I think it's Ada, right? It's the original coach. Ada, yeah. Yeah, okay. So I'm Patrick McFadden, as we said. So I'm going to talk about building an application with Cassandra. I bet this is probably going to be, if you went and saw my talk at Cassandra Summit, this is going to be somewhat different. It's updated. So this is me. I work at DataStax, where I would put the Cassandra company. We employ most of the committers, and so when we talk about Cassandra, DataStax is really the company that is behind it. I didn't put my MVP thing up there, but I've been using Cassandra since 0.7, or it was like I like to say when it was stable. If you use Cassandra before 0.7, I'm sorry, we fixed it. You can follow me on Twitter. There's my Twitter handle. So my job as a solution architect at DataStax is really just about getting this kind of stuff done. Working with customers, I see some out there already, trying to get your ideas put into practice. I work a lot with customers, just trying to get things together and out there and scaling. And so I get to do some really interesting things, and I learn a lot of interesting things about how people are doing things. So I'm going to try to filter that into some sort of conversation here. So again, we're going to start from scratch though. And these are things that are best practices, things that I know, that I've learned out in the field, that I can help you build your first application with Cassandra. Actually, let me ask you real quick. How many use Cassandra right now? Ooh. Jack, you don't count. Jack's a co-worker at DataStax. He knows a lot about solar, so if you want to know that. So that's not a lot of hands. Okay, we're going to have fun. All right, so here's our goals. So we're going to start from scratch. We're going to take a brand new concept for an application, and we're going to answer that very first question, which I always hear in any data modeling type organizational, when we all get together in a room, what's data model? And so we're going to answer that, hopefully, and get you past that initial phase of using Cassandra. I think everyone probably has used MySQL. They know, I got to do my entity relationship diagrams. That's where we get a little bit of a vapor lock when it comes to Cassandra. How am I going to model my data? So we're going to do all that in CQL3. CQL is Cassandra Query Language, which is similar to SQL, but it is for Cassandra. That's the C part. CQL3 is really where we're standardizing a lot of our data modeling language, so I'm going to just use that. We're going to generalize that some using SQL, then I'm going to have a couple of Java examples up there. Sorry, no Python. I knew I would have. Let me change out my slides. Yeah, okay. B, all right. And thank you for these. So we're going to do Java instead. So anytime we build an app, we're going to start out with our very first set. We're going to conceptualize the application. I've already come up with one, so you don't need to provide that. We're going to identify entity tables, just like you would in a normal relational database. And then we're going to identify the query tables, and this is where we diverge a bit from relational. So I'm going to explain how all this works. We're going to do some coding, and then we're going to deploy this thing out, make a lot of money, because it fit into the next goal thing. So here's our concept. KillerVideos.com. Some of you have already seen this website. So my killer idea is Killer Video. And it's going to be a video sharing website. I know, there are none out there, right? But mine's cooler, because it's using Cassandra. So it's just a real simple site. You know, it's going to be like my weekend project on Hacker News. And I have some features that I'm going to have to enable. I want to make this thing scaling, so whenever I do have 5 billion users, it'll be fine. So let's talk about some of those features. So just the basic features. I want to be able to post video, of course. I want to be able to view videos, and viewing a video generates data as well. That's not just a click on a button and you watch the video. There's going to be stuff going on behind it. I want to add comments to my videos, of course, because I want to tell everyone how great it is, or vice versa. We want to do video ratings, because of course that's how you get them to the top of the queue, and tag them. So these are just basic. I think everybody's probably figured these are the basic features of a video sharing website. So how are we going to enable all of that with Cassandra? So again, we start with entity tables. Entity tables, just like in a relational model, here's a basic storage unit. Here's a person, a video. We're going to look at that. All right, so now we're getting into here's some actual SQL. So now we're getting into the real part of this. So the users table that I've created is just like what you would see in MySQL or Oracle. We're going to have username, first name, last name, email, password, and create a date. And yes, that is very similar to any other relational model. Fine. Cassandra doesn't really care. There's not any constraint saying you have to have some craziness because it's using Bigtable. And that is true. It is using Bigtable. You can have 2 billion columns in your row. That doesn't mean you have to, but you can if you need it. So I'm going to make it so that the key is username. Now that's probably a little different from what you're used to in, say, relational, because you usually use like a sequence or an ID. In this case, we're just going to use username. And the reason we're going to use username is because that's going to be indexed. That's a key that can be looked up. So in Cassandra, that key is hashed and then put into the cluster. So it's indexed, so it's fast read, and it's also cached in most cases. So I'm going to say that's my unique field, username. So whenever I create the table here, just like I would with this is CQL VDL, I'm going to create a primary key username. And so that's going to make it unique, but also make it the row key. Now, if I need to do any kind of lookup, say on first name or last name, I can use what's called a secondary index. Secondary indexes are much like in a relational database, except they really like the low cardinality a lot. So if you had something like email, you don't want to use a secondary index for that. You want to use it for something that may be more common, like last name. There's a lot of grouping with that. This is there for if you need to look up on in Cassandra, say where last name equals McFadden or something like that. It's a perfectly acceptable way to index your data. I'm going to show you a cooler way to do it, so you can be cooler than your friends who didn't come to my talk. And this is actually a lot faster way of doing Cassandra indexes. So, like I said, you can have 2 billion columns in a Cassandra column family, and one row is going to get pretty big. So, the schemaless. We always hear about, NoSQL, schemaless. Yeah, there's some schema in this. Here's the schema, but it's not fixed. You can add columns to this anytime you want to. And that's much more flexible than a relational database. You don't have to do an alter table. In many cases, it's just add the data, you're good to go. And so this is really a big difference. I remember I was an Oracle DBA for a long time, And I remember those moments where we had to do an alter table on a production database, and look out, you're going to shut her down. Never had that problem with Cassandra, which is why we have a lot of people that love Cassandra. So here's some Java code, because we're at Walmart. So this is Java code to insert a brand new user, and this is using the Hector library, which is one of the 2 popular Java libraries for Cassandra. There's also some great Python libraries for Cassandra called Picasa, PHP, Ruby, .NET, if you like that kind of thing. So there's lots of choices out there. In this case, so what we're going to do, the underlying, in this particular case, the underlying communication is using Thrift. So it's all about the mutation. So we create a mutator, which is basically, I want to connect to a key space. The key space is the top level of your cluster. Key space is like a database in MySQL. Key spaces contain column families, which are like tables. So I'm going to connect to a key space, which is like a database. And then right beside the try block here, I'm going to add these insertions. So I'm going to grab the user. And so what I'm doing here is this factory is I'm just creating these strings. 1, 2, 3, right here. And by adding all these strings in there, and then with one row key, where's my row key? Yeah. The row key is this get username. So I said, I'm going to use the same row key 3 times, and I'm just going to add 3 columns. And then I do an execute. That row gets inserted into the database. And so, and we'll never, ever, ever hit the catch block. The inserts are, of course, what everyone knows Cassandra for. They're super fast. And we're talking thousands and thousands per second if you need that. A million per second if you need it. And what's interesting is an insert and an update are exactly the same operation in Cassandra. Because it's a write once. You're not going to update data because what happens when you have to do an update? You have to do a read first. We don't do that. So it's all because there's a certain amount of velocity with that particular piece of data. And this is really an important concept. This is how we can get Cassandra data so fast. It's because we're just doing an insert every single time. So I'm just going to show you the insert and just know that the update is pretty much the same thing. As a matter of fact, you may never write update, you just write an insert again. They don't overwrite those columns with the proper data. Okay. So our video table. Now this is a good example of a one-to-many relationship. And I get that question a lot is, how do I go one-to-many, or a many-to-many? We're going to do a many-to-many here shortly. Now the video is owned by a person, but we want to sort that by video ID. So the video ID is a unique ID, but it's not a sequence. Now, and this is just a concept with any kind of large-scale distributed system. Doing a sequence with a large-scale system where it's distributed over, say, multiple data centers is almost impossible, and it's a huge problem. Don't even do it. So what we would like to do is use a UUID. UUID is, of course, guaranteed unique. You can generate one from almost anything. I can do it from a command line on my Mac. But the UUID is a great key. That's a good, unique key for Cassandra. And that's one of our supported types. So the UUID will be for the video ID, and we have all the other stuff. This is just like a regular entity table, except it's going to have the username in it, and that's going to link back to the user. So that's how we create that one-to-many relationship. And the reason we're going to use the video ID instead of the video name, like we did with the users, is so we can have more than one name. If you want to have a video name that's Killer Video, well, maybe your buddy wants to do the same thing. I'm sure there's going to be a lot of, wow, this is the best video ever. So we're going to use video ID as the uniqueness in this. So I also am adding tags in this particular field. One field. Now, you could do that in some sort of format. You want it delimited, you can put it in JSON, what have you. This is not the only place that tags are going to exist. And this is where we start getting into the denormalization of your data. In Cassandra, it's perfectly okay to have your data in 2 places, because sometimes that data needs to be in a different format or in a different place for access. We're trying to go for speed here. This is all about velocity and making sure everything is fast and distributed. So we're going to put the tags in here. So when we are talking about the video, we're accessing one row. We do one row lookup, and we get all the data we need, say, to display on the website. Because our website is going to be fast, because we're going to have 1 billion users, right? So whenever I ask for a video, I get the name, who did it, the description, and the date. So I put on here an indexing username. May not be a best plan. We have a better idea. So indexing username, there's not going to be a lot of those, and putting a secondary index will work. You could possibly do that. And I'm going to show you a different way that's probably better in Cassandra. You can do that. Probably, I've seen plenty of places where they have done it, and it does work. But I like the faster method because I'm all about speed. So here's how we get data out using the same Hector, same Java, but this is a get. And so the mutator is when we put data in. That's a fair concept. In this case, we're going to do a slice. A slice is because of how the data is arranged in this. We're going to take it from one point to another. So what I'm going to create is a slice query. I'm going to set the column family to videos. The key is going to be our video ID, which is UUID. I'm just going to grab these 4 column names, and then I do a slice query execute, and that's it. And from there, I can get the values out from directly out of that object. It's going to be like a result set. This is not a JDBC result set, although there is one coming. The result, you can get column by name. And again, you don't have to have a fixed schema. You can put any column name you want in there. I could put a column name called Selena, and it would just say it's not there. So it doesn't matter, but in this case, because I had a fixed schema, I knew which ones were going to be there. That's the way I handled it. Same with the insert, I should mention too. You don't have to have that schema defined to put insert a new column. You could insert a new column of any name. It's going to insert it. It's not going to stop you. It's just going to create a new column. So that's where the schema for you comes in. So I told you we're going to have a many-to-many, and here it is. So comments. So there's going to be 2 slides on this. We have the conceptual slide and then the reality slide. Now follow with me. The conceptual slide, so here's our create. We're going to create this table of comments. It's going to be composed of a video ID, a username, and then a comment timestamp so we can sort it. But really the many-to-many is there's many videos and many comments in this table. And so we want to have, so videos have many comments, comments have many users. So we want to make sure we can identify that relationship in Cassandra. This is one of the things that I spend a lot of time with users and groups, different groups with, because this is really a core concept that a lot of people have trouble with. So there is no entity relationship diagram for Cassandra. There's no relationships. It's not a relational database. That doesn't mean you can't do it. It's just there's no relational integrity, which is fine because relational integrity will slow down the database. We're trying to go fast. We want to do thousands of writes per second. We want to do 1 million writes per second. You can still do it with a little bit of training. So I create this table with the video ID and username being the one-to-many relationship. So as you look at it with CQL, now this is where the conceptual goes in reality. As you're looking at it with CQL, it's going to look a lot like a table. CQL is going to make this relationship look like a table. It starts with video ID and have a username, comment, timestamp, and a comment in a nice tabular form when you ask for it, when you select it out of the database. But there's a different reality going on, and I'll get to that in a minute. So this is the reason we're going to do this in some sort of order with comments and the timestamps is because of a slice query. And I'm going to show you how a slice query works in a minute. But a slice is very efficient. Get a row key, go from one, like the beginning to the end of a row. Very efficient operation on the disk. It's a single pass on the disk. Cassandra stores its data in a string sort of table, an SS table. And that makes it very efficient on read because when you say I want to go from A to Z, is in order. So that's what makes these kind of queries very efficient. So this is conceptual. Let's go to reality. So CQL, the way that it makes your data look, is actually hiding the details. And the details are that what you're really doing is you're creating this massively wide row. And this is where traditional Cassandra folks, this is where they used to live. And CQL has abstracted this quite a bit, thankfully for a lot of people that have to start this fresh. They don't have to understand how composite keys or wide rows work. But this is actually how it's storing it on the disk. So what it's doing, video ID is still the key, but what is happening is the columns are going to be a composite of that username and a comment timestamp. So that creates a unique name of a column. And then the comment will be the value of the column. So as new comments are added, a different username, definitely a different timestamp, and a different comment are all added in time order from left to right. So potentially what you get is you have, let's say you have a video that's very controversial or that everyone wants to talk about. You might get a video that has, say, a couple thousand or maybe even a million, let's say a million comments on it. Well, that's okay. A wide row is going to be able to accommodate that. And that's going to be a very efficient read from the disk. Well, let's say that on our application, we only want to be able to see, say, comments from yesterday, from like the last 3 hours. Well, whenever you create your slice query, you say, here's the video ID, and I only want the timestamps that start from here and end here, and end here, and that's the only data that I want. Single pass, you get the data out of that. That's what makes this a really efficient query, is how it's actually stored on the disk. So you get one column per comment, one row per video of all the comments for that. That's a very efficient way to store your data.
Is there a limit?
A limit?
To how wide?
2 billion rows, or 2 billion columns. So you can only have 2 billion comments. If you're going to go above 2 billion, I have some partitioning strategies that might help. But if you're doing 2 billion comments on your videos, then you probably need a better video. All right, so the rating system. Now we're going to get into a different type of column family with ratings. And so I kind of derived this. I came up with this example to use counters, because I like to use counters. Counter columns are a really interesting way to manage data in Cassandra, because it's not setting data and it's not updating data. So what a counter is a special construct inside of Cassandra that essentially allows you to do an increment or decrement. And that is, I think there's several NoSQL databases that have this. I think MySQL has some sort of setup like this, but this is very efficient. So a counter is a single call. I want to increment it by this much. I want to decrement it by this much. I'm going to use it in this case for my ratings. Now this particular table is pretty small. I'm going to have the row key be the video ID, and then I'm only going to have 2 columns. So I'm way short of that 2 billion I potentially could have. But what I'm going to use that for is because those 2 columns are going to be still pretty active. The way I'm going to do this is I'm going to have a count. So this will be a cumulative count. So if someone clicks on it, I want that to be 4 stars. It'll increment by 4. If I only want 1 star, it'll increment by 1. If I want to give it 3 stars, it'll increment by 3. And then the total, how many times did it get clicked? So what that gives me is a running total as people are clicking on that button, rating the app or rating that video. It's a running total. So what I can do from the application side is like, hey, I need a rating for that. This is where the speed comes in. Now, as I'm looking at a video on my website, one video ID, I get 2 numbers out of there. I just divide one by the other. So I say I got a 23 total, and then my count is 5. So 23 divided by 5, I got an average rating of 4.6 on that. That's 1 call to the database, and then a quick bit of math, and it's on the website. Counters are very efficient in that regard. So the create is different. Here's the limitation for counter column families is they can only be counters. They can't be anything else. The only thing in that column family is counters. One of the reasons why this is a very small column family or table. Question in the back.
She just answered it.
Okay. I just sensed that. Everyone's like, wait a minute, can you blend those? No, you can't. So I wish you could sometimes. That would be better for denormalization. But no. Yeah.
Quick question. So, like, on the basis of like how they are accessed, which table is accessed most, or which columns are accessed most? Like, say, we want to always get the column family. Within that column family, we want the user ID or the username. So, do we actually store the data in a way that like AWS region server kind of stuff, like it only goes to that server or that particular block of data and find it out?
You're talking about the underlying operations in Cassandra?
Mm-hmm.
Okay, the way that I have a picture that might help, but let me try to answer your question. The way that Cassandra works is by when you set up a cluster, you assign it a token. The token then is used to dice up a range of keys. So you have like a circle, that's what we look at, you see a ring. You dice up that circle into different chunks based on the token. The token is what assigns a certain range of keys to a particular node. So that, whenever you say, here's my key, it hashes the key, says, okay, what token would that range would that belong to, because it's aware of the cluster. And so this is what's happening on the node. With Cassandra, there is no affinity. You don't have to write to one node. There's no master. Everybody is the same. So when you set up Cassandra cluster and you client, the client can read and write to any node. The nodes are going to figure out, oh, that's not my key. I'll pass it on to the person or to the node that it belongs to. Same with the read operation. That also is affected in the replication as well. And we'll see a little bit of that in a minute. But that is really the underlying thing, is that the tokens and the keys are really, that's how they're linked together. And there is a node that is responsible for that data. It's just that everybody's in cahoots and they all work together. It's a great team. All right, so my events. Now, remember I said whenever